Just noticing there that even by the time I got that video up, it's about, you know, 1:15. So I'm going to try, I'm just learning as we're going here. I'm going to try and have maybe the videos up a little bit before class time every day. But obviously just watch them if you want during class time, and I'll give you hopefully an hour afterwards of where you can still contact me, and I'll still try and put up other videos to clarify stuff if you need to. So I guess we'll just learn as we go along here. So take your time with that first video. Just kind of get used to the outline of it. I'm going to go do an example now of, I'm going to keep with that example about the Ryanair claim, and I'm going to do the hypothesis test in more detail. So I'm going to do a full hypothesis test. Hopefully you're happy with the outline. Just take, like I said, you know, maybe you need to watch it a second time just to let it sink in. We're going to do kind of like, we'll do an overview of the claim up here. We'll do some maths, and then we'll decide on our conclusion about their claim. And that makes sense. We're being clear about the claim, we do some maths about the claim, and then we make our conclusion as to, you know, whether we reject their claim or not. So I'm going to go back here. Their claim is, again, 93%. So apparently the proportion of Ryanair flights that arrive on time is equal to 93%. We looked at a sample of 625, so I'm just trying to put all the information here, sample size, which is N, is 625. 535 were on time. That's what we have, 535 flights on time. So that's kind of the information from the question. I am now going to go to my hypothesis test. And my null hypothesis, I need to nail down one statistic. Now, lucky for me, it's quite clear in this example. I've picked a very nice one to start with. It's quite clear that the percent that we're going to like nail down here is 93%. That might seem really straightforward to you, but there'll be other questions where it might not be as clear as to what the null hypothesis is. So it's just very important that here we nail down that percentage. And at the minute, their claim is, you know, about the amount of their planes that arrive on time. Our null hypothesis is not always the same as their claim, but in this situation, yes, it is. So our null hypothesis is that the proportion of flights that arrive on time is 93%. I would potentially write that in maths for sure, but you could actually write it in English for yourself, because we're going to be talking in English anyway for the conclusion. So I'm already, again, unless I'm under time pressure, I'm helping myself here. The proportion of flights that arrive on time is 93%. H1 is the alternative to that, and that's why this is very important that we get one percentage here, and the alternative hypothesis is that P, the proportion of Ryanair flights that arrive on time, is not 93%. And again, you can write that. The proportion of flights, I'm just writing a little bit shorthand here, that arrive on time is not 93%. So that's the very first part. That's our introduction. We're being as clear as possible about where we're going with this. Now we do some maths. So you have a choice here. That's my dog thing. So we have a choice here. The maths, we can do three things. We can do a confidence interval. That would generally be my option. I like doing confidence intervals. It's probably going to be the first thing that I suppose you were introduced to Z-scores first, but you know, they're pretty handy. So I'll probably do this one by a confidence interval. But I also have the option of doing it by a z-score. And then and I have a third option, which we haven't spoken about yet, which I never do unless they make me. So I'm going to stick with those two options. And in this situation, I'm going to do it by a confidence interval. Right, so what do I need for a confidence interval? I need my statistic plus or minus 1.96 times my standard error. So what is my statistic? Well, a statistic comes from a sample. And off I went, let's say, and I went to Dublin Airport and I watched 625 Ryanair planes land, and then I had to leave. I just didn't have any more time. And out of those 625 flights, 535 of them arrived on time. So there's my statistic. 535 out of 625. Plus or minus 1.96 times the standard error of, now, is the data, is that P or is it X bar? You know, was the data categorical data or was it numerical data? Well, if you think about it, firstly, that's the proportion of the flights that arrived on time. So we are doing P hat. Or if you even just think, what was the question that I was asking as the planes were landing? The question I was asking was, is the plane on time? Yes, no. So that's categorical data. So P hat plus or minus 1.96 times the standard error of proportions. If I have P, and I don't, like, I have a claim that Ryanair have met, and yeah, I do want to, you know, assume they're telling me the truth, but the statistics that I have is what I'm going to use, so I'm going to use my P hat here to fill this in. So I have 535 over 625 plus or minus 1.96 times 535 over 625. 1 minus 535 over 625. I need to make my square root a bit bigger. All over n, what was my sample size? 625. And then you're just going to your calculator. We have 535, so 535 over 625. And we want to go plus, well, do you know what? I'm actually going to save that. So 535 over 625 stores A in my calculator. So 535